Alright, I'm gonna pick back up with this gganimate direction that I'm thinking of. So, as a recap, not a ton of code, but uh, it is using a pretty powerful library to do something that could be a lot more difficult otherwise. Let me also double check. I've got the microphone going. All right, so what have I got? Um, and then also, where might I go with this? So, one thing I'm also contemplating is learning the plumber library. This allows you to create your own API, which would be useful for basically setting up our code to run on some server that I could have running constantly that I could interact with from other places. So this could be good for something that I could interact with through a web browser, through my phone, through a Raspberry Pi or some device that I might have running wherever. Um, but I don't have a deeper thought than, maybe I want to learn how to play with this tool. One way I could play with that tool is I could make an API where you pass it in some parameters and it sends you out a GIF made with this script. But let's get to that later. Let's start by seeing what I can do. So, getting rid of the background, that's something that should be straightforward. So, ggplot, uh, tidyverse.org. Let's check out the cheat sheet. Graphical primitives. Okay, let's try plus theme void. Let's run it all again, make sure it works. Okay. Oh, here we go. It's going kind of slow, but it's doing something. All right. So, gotten rid of the background. Let's get rid of the legend also. Uh, oh, here we go. So plus theme legend dot location equals. I think if I put null, that'll just eliminate it. That didn't eliminate it, did it? Let's look at the help page. Legend, blah, blah. All right, legend title, yada yada yada. Legend box. None. Let's try that. Oh, come on. Is it legend dot location, legend.position. Cool. All right. So as long as we made a discrete change, let's go ahead and make a commit. So let's say we eliminate legend and background. Cool. Let's go ahead and add some labels, and we can make the title. I wonder if this is something that we can. I mean, this should be able to. Yeah, this is able to animate. L2. Failed to plot frame. Why is this not working? Legends, labels, guides, annotate, labs, add a title, or a caption. I'm going to do it as a caption. Still not working. Alright, so run gganimate, run the renderer, and okay, provided file doesn't exist. We'll run this function. We'll run gganimate. Within that, we're running animate.gganim, our renderer, png dim, CLI abort, provided file does not exist. So it's when this gets called in the background, right? So we're just hitting animate, and it's saying, let's look for that inside gganimate, and let's figure it. We're printing the result. When we're doing this, we're going to do animate.gganim. We're going to look at the renderer argument, which... Didn't I solve that? I thought I had figured that out. I did this on a different computer, but this should be synchronized. We'll see. If I've got a different version in Dropbox, I'll get a case conflict version. Huh. Whatever. All right. So let's comment that out for now. See if it works without that. I think that's what broke the code. Okay, perfect. So I'm going to leave that alone. I do want to label it with time, but let's start by fixing the timing. So let's think about making this a function. So what would I want to be able to change with this? I want to change how long it goes. The size, I really just want it to kind of mostly fill the screen. I might want to change the color. I might want to change the function, right? Is it going to be a sign, or is it going to be something different? But let's leave it as just time for now. So, um, okay, now look at this. We make a thing, yada, yada, yada. We do some transition states on this plot. Using transition state, blah, blah, blah. Okay. Ooh, labeling. This gives me some hint for here. All right, so I want GG title. Time in curly braces. Let's see if that works. Okay, cool. It didn't do what I wanted, but let's make this. See if that does it. Okay. Okay, that's not doing it. But transition states time. Does it have to be square brackets? Or not square brackets, double quotes? No, single quotes in there. How's it getting in frames? Well, let's try this. See if frame is something that gganimate is figuring out automatically. It is. Cool. And I think it does 100 frames by default, and then it starts over again. Let's see what closest state does. Awesome. This is basically what I want. So let's call this subtitle equals. And I believe there should be a way to center this. So this number, I want it to be down here. Whatever. I've got it doing something. All right. Okay, glue syntax, insert frame variables and plot labels. Different transitions provide different frame variables. Okay, closest state only makes sense for transition states. And I'm using transition states on time. So there's going to be different transitions, but whatever. We'll see what I learn. Single measurement. this stuff, although that's pretty cool. Enter and exit. Ooh. This tutorial would be very useful if I wanted to show different data. But really I'm just sort of inventing something. I'm just trying to make an animation. I'm not really trying to do something data-centered, but I will make up data to do that. See what happens if I do that. Okay, didn't work. Once again, sort of flipping back and forth between things. What I'm doing here is thinking about a way to generate this size parameter. And I also need this size to get bigger, because right now it's assuming that I'm making a scatter plot, and it is very reasonably making the point small. It's making it a point. I want it to be a big old circle. I started to look at polar coordinates last time, and I think that's where the answer is. But still, I want to start by having sort of a nice sequence of variables that are getting bigger and smaller. Right, so here we go. What is it? Sine of pi is 1. I can never remember trigonometry. I mean, I could. I don't put in the effort. Cool. So 17, that's what, 1.7. So that's about half pi. So what, 32-ish? We come back to 0. So that's sine of 0 is 0. Sine of pi is 0. Sine of half pi is 1. Sine of 3 half pi is -1. All right. Cool. So I'm generating something like this. I could just make sort of a bouncing ball rather than an expanding circle, basically a pendulum. But no, I like the circle. If the circle prompts you to breathe with it, which is relaxing. All right, so one breath would be inhale, hold, exhale, hold, start again. So, let's call this X for now. X will start at 3.5 pi. Sequence from there to somewhere else. So if we start at 3.5 pi, here is 2 pi. Okay, 2 pi is 0. 2.5 pi will be 1. 3 pi, 3.5 pi. Okay. All right. maybe trigonometry would have fit in my head better if I had r when I was in high school or whenever we learned that. Okay, so I want to go from -1 to +1. So sine of 2.5 times pi is +1. Well, no. I want to go from -1 to +1 back to -1. So let's call this 3.5 pi. Um, oh, I know what I'm missing. I better run that through sine. Cool. All right, so there's sort of one cycle. I want to stretch it out a little bit here and at the end. So maybe what I do is I break this down into pieces. So breath cycle will be a vector that starts from a sequence from 1.5 times pi to 2.5 times pi, going by 0.01 for now. And then we'll do a repetition of 1 by 10 sequence from 2.5 times pi to 3.5 times pi, going by 0.01, and then rep 1, 10, sorry, rep -1. And then this sequence will run through sine. All right. So stretch that a little bit. I could, again, make this sort of more programmatic, but I'm just fiddling right now. I'm going to make a big mess, and then I'm going to clean it up. All right, so 10 repetitions, a little bit slow. I really should be thinking about how to sort of map this to time a little bit more elegantly. But here we've got, hypothetically, the size of our circle. Starts small, gets big, hold, gets small, hold, and then we'll repeat. Right? So this will be sort of a nice breathing exercise. So this length of hold in, length of hold out. Let's go ahead and make that some sort of variable. So we'll put it in here. Let's indent it. Okay, so we need to think about basically we got these 4 sections: the inhale, the hold, the exhale, the next hold. So if we say inhale equals 3, exhale equals 3, hold, first, the hold when your lungs are full and the hold when your lungs are empty. We'll just leave them all as 3 for now. So, we've got, let's call it a 12-second cycle. what we need is we need to think about how many frames per second. Now, I think it was like 15 frames per second, which means we want sort of 15 graphs per second. So we want 15 times 12 graphs. Huh. All right, I'm going to stop here. I'll come back later.